Okay, so our next presenter for this session is Paul from the University of Minnesota in the Twin Cities. Paul, why don't you introduce yourself and go ahead. Paul, I'm not hearing you. Are you there?
There you go. Can you hear me now?
Yes, I can.
Excellent. Hi, welcome. I'm Paul. I'm a student at the University of Minnesota doing programs with the Minnesota Space Grant Consortium's student ballooning team. So, and last semester, fall semester, here we ran a class called stratospheric ballooning for freshmen to get involved with and to start to learn some of the basic skills. So I'm going to talk a bit about both what we did there, its use for the freshmen, and the things that I as a TA took from it. So yeah, again, this happened through the aerospace department here, but it involves students from a whole lot of majors. And yeah. All right, so what is stratospheric ballooning? Why do we do it? And what do we get from it? So one of the main important parts of the Space Grants mission is to bring new students into the STEM pipe flow, in particular space-related studies. And so, but one of the issues with that is that spaceflight itself is really, really expensive. So sending something actually into orbit is very pricey, but we still want to give students that sort of that exposure to spaceflight. And so a really good way to do that is with high altitude stratospheric ballooning. So the goal of this class specifically, and of all stratospheric ballooning that the Space Grant does in Minnesota, is to, as it says here, help undergraduate students build these kind of skills and to motivate their interest in space studies. So a program like we're going to talk about here, the students learned how to put together a payload, how to fly that payload, and how to collect data from it. And then once that data is back down, they did analysis on it and a presentation. So where does the stratospheric ballooning go, and why is it useful to us? So we say that it goes to near space, which is to say it goes up into areas of the atmosphere, the upper stratosphere, that where the air is so rarefied, so thin that it is essentially a space-like conditions. So the temperature is much, much lower than it is here on the ground. At the places where we're flying, it can get down to -30 or -40 degrees Fahrenheit sometimes. And then also you can see that at this point, the pressure is much, much lower. It gets to close to a space-like condition. So we call this near space. And one of the advantages of going here is that it is much cheaper than sending something to space. Another advantage is that the balloons come down after 3 or 4 hours. And so students can fly the same payload multiple times. They don't have to do the same amount of absolute rigorous testing that you might have to send something to space. And so they can learn a lot more, a lot faster from it. So this is an example of a pretty common balloon trek that we might do. You can see it starts down here in the southwestern part of the state. And usually we fly, this is actually a fairly long one, but usually we fly from somewhere around Mankato, and then it flies it flies eastward for a few hours and lands somewhere in the Rochester area. Another aspect of this is that the class that I'm talking about here was a freshman seminar. So these were started over 10 years ago as a program by the Space Grant initially with this class exactly, this ballooning class. And the idea was that freshmen are coming into these STEM programs, and there's a lot of work you have to get out of the way that isn't particularly interesting and is kind of difficult before you can start getting to the really, really interesting and cool parts of engineering or physics or chemistry, whatever those fields may be. And so the idea of the freshman seminars was we'll give you a crash course on building initially a balloon, but it's expanded now to rockets or quadcopters or small aircraft. And so that you can, and then you will build one of these things and fly it. So you can get this hands-on experience and see what the major might be like once you have learned enough to start building real things as perhaps an upperclassman. So I, for one, participated in a class like this. It was not through the space grant, but it was a similar class where we built a small unmanned aircraft. You can see that the photo of us all there on the right there, on the left. And this was a really important class for me to take because it was that class where I realized, oh, I like this major. I want to be here. And so a really important part of the space grants activity is motivating interest in STEM by offering classes like this. So what happens in a typical 1301 ballooning class? There's, like I said, it's kind of a crash course. They get the basics of, here's where balloons go, here's how we track them and build them. We teach them how to do some basic electrical construction, and then also how to take data, how to interpret data, and eventually we take them on a flight, usually. In this case, because of the COVID-19 pandemic, they weren't able to come with us on the flight, so we had to modify the course just a little bit. We were able to meet in person, but students were unable to come on the actual flight itself, and so we came up with new ways for them to remotely monitor that data and to take a look at it while it was in flight without having to actually be there. So here's where I come in. I was a TA for this class. And so some of the things that I did were both helping things on the back end come together, but also helping the students in general. So on the back end, there's a lot of stuff that had to do with how do we take these individual student payloads and connect them all together with radios and make sure that the students can get that data and we can record it. So we used two different systems for this. We had a system that we were pretty familiar with that just radioed the telemetry, the data directly from the balloons down to the ground. And so the student payloads would, over a short range radio, send their data to kind of like a hub payload, and then that payload would send data back down to the ground. As it turned out, this actually didn't go super well. We had data for a short amount of time, but the balloons soon flew kind of out of range and it dropped off. Our second thing, though, was actually completely new. We were using something called Stratostar, which is a commercial platform that you can purchase. It's a little pricey, but you can purchase it. And it traditionally just sends its own data. It has plenty of sensors on board, and it sends that data through a satellite network, and then you can download the data online. But we worked with the owner of Stratostar, and we developed a protocol so that we could send our own data through that system as well to satellites and then back to the ground. And this was one of the main things that I as a TA worked on, as well as, and great thanks to Jason Kruger from Stratostar, who really helped us put that together. And another person at the space grant, another student there, Andrew Van Gerpen, who is giving a presentation later today on the other thing that really made this class work out, which was, you can see this printed circuit board up in the middle top here. And this was a pretty basic frame that all the students use to attach things to and to build on top of. And that's the pterodactyl board. And I think he's giving a talk about that later today. So it's really a cool piece in it. And so my job as a TA was to help students integrate with all this technology and move that together. But another really important part of, and obviously that was important to me because this is an extension, much as the students are learning a lot of new skills that were important to them to start off. I was also learning a lot of new skills that were a little bit more in depth and well suited for where I was at. Another really important part of being a TA, though, and I remember using this a lot when I was in this freshman seminar, and a lot of students used it here, is that as a TA who is accessible through email or just to meet up for debugging of code or this or that, I was often the first upperclassman that would be regularly available for these people, for incoming freshmen. And so it was pretty common for people to ask questions about I'm an aerospace student, so they would ask questions about the aerospace program or about professors or research opportunities. And so that was also a really important aspect of what I was doing, was to just sort of give people an idea of what's out there. And that's something that I use, and I'm glad that they did as well. So we've built these payloads. Let's go fly them. We had 4 teams who came out that we assembled for this class. All of them with excellent names, and each of them carried the same kind of basic pterodactyl board, as I mentioned, and that has a number of sensors on it already. Pressure, temperature, those kind of like fairly simple standard ballooning stuff. But then with each team also attached its own payloads to it, or their own sensors to it. And so you can see there were a lot of really cool experiments on here. So for example, the A team had a really interesting experiment where they had set aside a large chunk of memory in a Raspberry Pi, and they were looking to see if radiation in the upper atmosphere would start messing with the memory up there, start flipping bits. And so that was one of their experiments. We had other experiments with checking how the air quality was up there, or one student set up a marshmallow on the end of a pole and watched it as it went up and down. So these are the kind of things that none of this is groundbreaking science per se, but it's really important for students to get the experience of putting together sensors, testing them, sending them up, bringing them back down, and analyzing that data. And that's a really critical skill, and this is often the first time that they've been exposed to it.
1 more minute.
Yep. So we sent up these payloads. One of the cool things was that we got to we live streamed it so that the students could watch it. And you can see here, this is just a clip of the live stream itself. And then again, this is the flight track. We had a pretty long flight this day, so it was a little bit messy. And in particular, on the recovery stage, one of the things landed in a tree, which is unfortunate, but it happens. And eventually, after a lot of hassle, we got it down the next day. So in conclusion, ballooning is a really useful technique that we can use to that is useful for us to get a better understanding, but really it's critical for students to get a first exposure to here's what spaceflight, or in this case near spaceflight, is like. Here's what engineering will look like. And it's important to all the students who are involved, including the TAs, to get new skills to and broaden their horizons and become more engaged in STEM. So yeah. All right. One last thing here, an upcoming project for us is that there are going to be eclipses coming in 2023 and 2024. And the Space Grant is intending to do a lot of ballooning for that and send up balloons into the shadow of that eclipse and take pretty cool data from it. So, and that's a nationwide experience with lots of other states' space grants. So. All right, thank you very much. Do you have any questions?
So I'm going to lead with a standard question, twisted a little bit. You talked about why NASA might be interested in people being trained this way, but does NASA itself actually use balloons? Do they really care?
NASA uses some balloons itself. But oftentimes in pursuit of activities like this, and I've got a video running back here. This is a video from our one of our student payloads once it's reached pretty close to the top of its flight. But so yes, NASA does use balloons in flight pretty frequently, although often in for student activities like this, but they also send up fairly large balloons. There's some that happen, if I'm not mistaken, in the Antarctic to study different things like that. But balloons are often are also a very common technique used in other parts of the government. So for example, like the National Weather Association will send up plenty of balloons to monitor weather traffic, weather conditions and things like that. And they're also common for scouting around rocket launches or other things like that. So it's a useful skill that gets used a lot of different places.
Are there questions from anybody else in the audience about this talk or this topic?
Sorry, I was just wondering, like, if you're working just with like mostly like mechanical or industrial engineers, would you have any suggestions for how to focus this project? Like more on one set of skills? It sounds like you're working with a lot of different people.
Yeah, so one could certainly focus this topic into different parts of engineering. So in particular, based on what you were flying. So in this case, a lot of the people were aerospace. And so we were focused a lot on that, the basic, like putting sensors together, that kind of instrumentation work. But one could easily imagine shifting the focus of it to to putting together different kinds of payloads and on the different aspects of payload building that might tailor itself better to do.
I've got a question for you, Paul, and that is, I want you to freeze your video when it shows a dot in the sky just slightly to the left of the sun, right there.
Yes.
What is that?
So this red thing up here is
No, what is in the middle of the screen, just above the
screen.
horizon?
Yeah,
white
that right
dot.
there is the moon.
You think that's the moon?
I
I'm
think
just
so, yeah.
curious. It might be the
Yeah.
moon. It might be the other balloon. There were two balloons flying down that day.
That's possible.
We could figure
Yeah.
it out by doing some geometry. So
I
just
suppose
curious
so.
if you already knew. I hadn't noticed that in the video before.
Yeah, that's pretty cool.
Okay, thank you for your talk. So our session is over. I put into the chat, so open up the chat window and you'll see it, hopefully, a link to a Google form, and that will allow you to vote if you are interested in voting for the best presentation in this session. And so I will leave that open, but only for about 5 minutes. So by all means, thank you to all the speakers. These were great talks. And if you are interested in voting on the best presentation, you can follow that link and do so. And I think it says that if there's a tie, then I get to cast the tie-breaking vote, but otherwise I don't plan to vote. But thank you again. And remember that this room is only used for this session and then one right after lunch. And so what you should do is you should go to the main room. One problem about going to the main room is that I noticed last night that in the abstract booklet, the link to the main room was incorrect. The text on the page was fine, but the link was incorrect. I'm going to stop the recording because I don't need to record this.